All right, just a recording going over activity confidence intervals, one proportion. So we're going to investigate percentages, proportions, things like that. A financial officer for a company wants to estimate the percent of accounts receivable that are more than 30 days overdue. He surveys 500 accounts and finds that 300 are more than 30 days overdue. Construct 90, 95, 99% confidence interval estimates for the true proportion of accounts that are more than 30 days overdue. All right, just fixing a typo here. Assume that data comes from a distribution that's approximately normal. So the first thing I would do is define what a success is. All right, in this case, kind of weird to think it, but it's a negative thing. More than 30 days overdue. All right, I'm gonna extend the highlight here, make it look a little nicer. 500 trials, all right, those are the 500 accounts that were selected. 300 of them were more than 30 days overdue. The proportion, the p hat, sample proportion, is equal to number of successes divided by number of trials. All right. We're going to use this formula to come up with our confidence interval, and you can see the first part of it is the p hat. The second part of it is the critical value. All right. So I'm going to type in equals norm inverse. I'll put in whatever my alpha value is divided by 2, then comma 0, comma 1. Lock it in. We actually want the absolute value of this, so I'm going to pop in an ABS in front. So my low bound is going to be equal to the p hat value. Now, everything here is pretty much, with the exception of z, in terms of p hat. So this part of it here under the radical, the part including the radical, is known as a standard error. But since it's all in terms of p's and n's, p hats and n's, then we can just kind of build our confidence interval formula without finding the result of this individually. So I'm going to do equals. My low bound is going to be p hat minus the 1.645 times, that's a square root of, we need in parentheses, the p hat times 1 minus the p hat. So I'll put that in parentheses again. A lot of parentheses here. 1 minus p hat. Close it up for the 1 minus p hat, close it up for the numerator, and divide by the n value, which is 500, and then close it up for your square root. All right. So as messy as this is, that'll compute this radical part of it, and altogether we get the low bound, which is going to be about 0.564. All right. As we've done over and over again, when it comes to confidence intervals, just same expression, change minus to a plus. All right. So we are 90% confident that, now I'm going to change the context here, that the population proportion of accounts that are more than 30 days overdue is between this and that. All right. Do the same thing with 95%. So I'll grab this. This time it's going to be 0.05 divided by 2. Low bound, same idea. I'm just going to copy it straight off. It says divide by 0. Let's see. Because I need to refer to my, and actually let me go back here for a second. I'm going to adjust this one because I'm never going to deviate from D5 and D7. right? So the D7 we want to lock in. Just make it a little easier in the copy paste component here. D7, get some dollar signs on that, and the D5 dollar signs. So the only thing that's going to change is the critical value. All right, so the 1.645, I wanted to become a 1.96. So let me lock this in. Might as well do it over here as well. Minus to a plus. And now let's see what happens. All right, am I pointing to the right stuff? Am I pointing to B18? Yep. So we're good there. Copy, paste. Looks like B26, well, I haven't put anything in there yet, but it's pointing to the right thing, so we're in good shape. All right, I'm going to take my conclusion, paste it on down here, make sure it's pointing to the right stuff. It is. Do the same thing over here. These are things that you might not have to update because I'm doing the update now, but that's how the magic works. I'm going to pop this in here and change it to a 0.01. All right, and so that adjusts my bounds. And so my overall conclusion is not really going to deviate too much from each of the individual conclusions because there's really no disagreement. Every value is in the 55-ish to 64, even 66 if you want. So you could say with confidence the percentage of overdue accounts is in the neighborhood of 55 to, I think I said 66%. All right. Now, the overall conclusion that we just came up with and what the financial advisor might look at as being useful information, it might differ somewhat, but I'd look at this and say, okay, so what does that tell me? Both endpoints, regardless of whether you're dealing with a 90%, 95, or 99, both endpoints are north of 0.5, right? So what that tells me is that the majority of accounts are overdue. All right, and this is a financial officer for a company. So basically he's trying to make a determination of whether or not people are getting their job done, assuming that's what accounts receivable represents, or people are paying their bills on time, or whatever it happens to be, is a reasonable amount. And if you find out, and being overdue is not considered a good thing, if you find out that the majority of individuals are overdue in this context, that I would imagine would be a problem. And so you'd want to look at that and say, okay, how can we fix this? It's sort of like if you were to take a test in a class and maybe you didn't do so well, maybe you even failed. And then you find out that the majority of students also failed. You'd say, okay, something's wrong here. Was it something about the test? Was it something about preparation? You know, things like that, right? But it tells you that there's an issue that needs to be looked into, right? So that's the whole idea behind this kind of stuff, all right? I'll highlight this to make it look a little nicer. And with that, you can move on to assignment 1, which is a similar problem, just a little bit of different context. And assignment 2 is going to involve some data collection, right? So you can get into that.